Hello, and welcome back to the web series Developing SPECTER using Innoslate's digital thread. My name is Mallory Jones, and I am a systems engineer here at Spec Innovations. In the previous video, I introduced the Break the Ice Challenge, previewed Innoslate's digital thread, and demonstrated the project management processes that initiated the Lunar Rover project. In this third video of the web series, I will demonstrate the cost and risk analysis performed to begin the Lunar Rover project and develop SPECTER Lunar Rover prototype. A cost breakdown structure, or CBS, was produced from a hierarchy chart. Each entity in the decomposition was a cost incurred by the Lunar Rover project, whether that be labor, supporting software licenses, or prototype hardware. In Innoslate, the CBS was created by going to Diagrams view, selecting the hierarchy chart, and choosing cost entities to be used for composing the breakdown structure. Once the parent cost entity was created for the hierarchy chart, it was decomposed into 4 types of costs incurred by the Lunar Rover project. This was labor, Innoslate integration licenses, rover hardware, and tools used to build the rover. This decomposition was done for easy roll-up and calculation of the total cost incurred for each type. To conduct a labor cost analysis for the Lunar Rover project, an asset hierarchy chart was also created to represent each type of labor utilized to perform work throughout the project. These asset types included a program manager, project manager, systems engineer 1, and systems engineer 2. Using the incurred by relationships, each asset was then related to a cost, that being the hourly rate of the labor type. Assets were also related to actions in the SOW action diagram using the performed by relationships. This represents the work and amount of work performed by the laborer during the Lunar Rover project. In Innoslate, the asset hierarchy was created by going to Diagrams view, selecting the hierarchy chart, and choosing asset entities to be used for composing the breakdown structure. Once the parent asset entity was created for the hierarchy chart, it was decomposed into the same 4 types of costs used in the CBS. However, here they represent physical assets. Once the cost and asset entities were related to the SOW tasks in the SOW action diagram, the discrete event or Monte Carlo simulators were executed in order to estimate a calculation for the projected labor cost of the Lunar Rover project. A schedule of 6.7 months and a cost of $91,000 was calculated. A variance was also calculated from Monte Carlo by iterating through the diagram 100 times. This variance was about $3,700. The labor types and hourly rates used for this calculation are just an example of how to conduct a cost analysis within Innoslate. A Gantt chart was also produced from the discrete event when it was simulated. This Gantt is a third way schedules could be produced in Innoslate. The first 2, timeline diagrams and Gantt charts, were demonstrated in the previous video. The last steps before beginning the Lunar Rover project tasks were to conduct programmatic and technical risk analysis to predict and prevent any major risks from occurring during the execution of the project. In the programmatic risk analysis, risks to the project's cost, schedule, and overall performance were identified and mitigated. For example, a performance risk is not being able to acquire a feasible prototype that suits the needs of the project. A cost risk is needing to hire a subject matter expert to build the prototype. A schedule risk is delivery of the prototype that is delayed more than 2 weeks. In Innoslate, the programmatic risk matrix was created by going to Diagrams view, selecting the risk diagram, and recording each risk by defining its level of severity and probability of occurrence. After the programmatic risks were identified and recorded in the programmatic risk matrix, mitigation procedures were developed to reduce the probability of each risk occurring. For example, in order to prevent the risk unable to locate a feasible rover prototype design from occurring, the subtask Select Prototype Design was added to the SOW. To confirm each risk identified was mitigated, a traceability matrix was created by opening it from the programmatic risk matrix. The mitigated by relationship was then used as the top row of the matrix. This process creates a cross table of the risks and the entities related to them using the mitigated by relationships. If a risk does not have an X in its row, the no entity is related to it using this relationship, and a mitigation technique needs to be implemented for that risk. This process was also repeated to conduct a technical risk analysis. Technical risks included those associated with the lunar rover's mission, such as environmental, functional, rover performance, and safety risks. For example, an environmental risk is lunar dust damaging the rover body's equipment. A functional risk is the excavator system's servo motor malfunctioning or burning out due to overuse. A rover performance risk is a rover not being able to reach the mission goal of collecting 10,000 kilograms of water in 365 days on the moon. A safety risk is a rover being hacked during its mission. Up next in the web series Developing SPECTER using Innoslate's digital thread is a video demonstrating Task 1 research. Thank you again for being here today, and I will see you in the next video.